Great. Recording is in progress. Welcome to the Bridge to AI discussion forum on emerging ELSI issues. So I'd like to introduce our speakers today. We have two, and they have a coordinated presentation. So I'll just do the introduction and then turn it over to Dr. Nebeker. So Dr. Camille Nebeker directs the UC San Diego Research Ethics Program and is a professor of public health with appointments in the UC San Diego Design Lab and the Herbert Wertheim School of Public Health and Human Longevity Science. In 2018, Dr. Nebeker co-founded the Recode Health Center, which is dedicated to conducting cutting-edge research to inform ethical practices in digital/AI health research, including machine learning and the use of large language models. The Recode Health Center supports education and consultation services to guide ethical practices in technology-supported health research across diverse research sectors, including traditional academic research and increasingly the health technology sector. She's a principal investigator with the Bridge to AI Center's Ethical, Legal, and Social Implications Core. And joining Camille today is Dr. Santosh Kumar, who is the Lillian and Maury Moss Chair of Excellence Professor in the Department of Computer Science at the University of Memphis. He directs the NIH-funded MDOT Center and previously led the NIH-funded MD2K Center of Excellence. He is also co-founder and CEO of Q's Hub PBC. Santosh's research has resulted in wearable AI for detecting stress, smoking, craving, drug use, brushing, flossing, and stressful conversations from physiological and motion sensors. His team has developed software platforms for smartphone, smartwatches, and cloud that has been used across the country for collecting hundreds of terabytes of mobile sensor data from over 3,000 human volunteers in their natural environments as part of various scientific user studies that are being used for understanding privacy risks and developing foundation AI models for wearable sensors. So at this point, I'd like to turn it over to Dr. Nebeker. And thank you. I feel like I'm introducing you every week now, and I'm happy to be doing it.
Thank you. And I wanted to kick this off because I want to set the context for how Santosh and I started working together. And I think we've known of each other for over a decade. And Santosh is a leader in digital health and mobile health and has been involved in this space for a very, very long time. And as many of you know, the NIH about 4 or 5 years ago started issuing bioethics supplement awards that are awards to study ethical dimensions of the parent grant. You know, whatever the main grant is, this was a way of kickstarting some of the ethics research that would complement an existing parent grant. And I've had the privilege of receiving a couple of those, one from NIDA and another one from the National Cancer Institutes. And about maybe a year and a half ago, Santosh and I started to talk more about something that he was interested in pursuing. And I think what I was really excited about to bring to you all here is this this ability to start working across disciplines. And as Brad knows, we've talked to a lot of our computational people about how they could work better together and how do we work with each other when we come from really different disciplines and approaches. And Santosh has really uncovered some interesting issues around re-identification of people whose data are in data sets that are coming from the wearable sensors, which is what he's going to be talking about. But I think what my big excitement about this is that he asked me to partner with him. He says, I have figured out how we can re-identify people that are using these kinds of wearable sensors, but I don't know how to bridge the gap and bring it to the audience that needs to know more about how this happens and what we can do about it. So I just wanted to give you, set the stage. So Santosh received one of the bioethics supplements, and I agreed to partner with him, and we started working together back in September. So we're about 6 months into this, and so Santosh is going to speak for a little bit, and then I will kick us off to a discussion that then Lori will moderate. So over to you, Dr. Kumar.
Well, thank you for a very kind introduction, Laurie, and for having both of us in your monthly meeting. I mean, I know several people in the audience, and Brad and I have worked together in the past, and but it has been some time, so it's good to see him on the call. And I have wanted to work with Camille for a long time, but we just needed the stars to align. And I'm just so glad that it ultimately aligned, and we are here together to pitch something to this community. And let's see as to how this goes, because we really want to benefit from the group's collective wisdom. So let me share my screen and we'll get this started. Okay, are you able to see my screen?
We see presentation mode,
Okay,
and that's fine if you want to keep it. There we go. Perfect.
okay. So, let me get this started with acknowledgements to NSF and NIH. So this, I think most of this you are already familiar with, that there is a large and growing problem of mental health. And sometimes we just think that it is about their life as long as they live, but it's also that they die a lot younger than most than the average population. And then if we look at in America itself, then more than half of Americans do live with chronic diseases. And so 90% or so of our healthcare in the US is spent on these patients, mental health or chronic disease patients. And so what can be changed, if we think about it, then there are lots that can be changed, and largely they have to do with our modifiable risk factors, which is our daily behaviors. Among them, sleep, diet, activity, addictive behaviors, and stress. So, and this is not something new to this audience, but wanted to get to the why as to what motivates us to keep working on this problem. So what have we done in the past 15 years? We started developing wearable sensors when well before the first iPhone existed. Then once we had the sensors, we developed the AI to derive biomarkers from the wearables. Then next, once we had the biomarkers, then we used them to trigger interventions. And then the difference can only be made if the fruits of our labor or our research discoveries, they ultimately get translated into products that people can use in real life. And so we have gone to that distance as well with both existing companies as well as the startups. So with all of this research, we realized that the data we collect from wearables, many of them seem like, okay, all they are collecting are just some biosignals. But once we started developing all this AI to extract infer these behaviors that can be drug usage, that could be smoking, that could be craving, and so on, we started to realize that these biosignals, they can be source of revealing some sensitive private behaviors. Sometimes as researchers, we don't even know as to what all can be inferred out of the data, and therefore our participants know even less. More recently, we started thinking, okay, some signals by now are well established, like GPS. They have a huge amount of re-identifying information. And so we have grown better equipped to deal with or protect the GPS data, deal with it carefully. But when we think about motion data from wrist-worn activity trackers or inertial sensors, it seems they're just so innocuous. What can they do? So so once we looked at it in more detail, we realized that they also have re-identifying information. That was a little surprising at the time. So that's what I'm going to talk about in more detail. So this work was published in 2021. So in this scenario, let's say an Alice, a participant Alice participates in a health studies, wants to contribute to science, and all of this goes to anonymized open data sets that's made available to the public. So, and then later on, she also participates in life insurance and of course wants to save more money. So she agrees to share the data that can save her some money on the health insurance premiums. So, what this scenario reveals is, by participating in the study at the time when she didn't know as to, what impact it may have later on in her life or her finances, those data are now available publicly, and the insurance company or another entity, they also have access to data from the wearables that she wears in her daily life. What will happen is that by using this anonymized public database, an adversary can develop a model that can be used to re-identify Alice wherever else she has that data. And if in this case it happens to be the insurance company can link the data that they have with the data from these studies. These studies, they are anonymized, but they do say, okay, all these participants had such and such conditions. They don't reveal who these participants were. But if they have the data from this wrist-worn motion sensors and they have the conditions for which the study was done, then that and the adversary has access to the same data in terms of motion sensor data, but then together with that, they have their identity too. Now you can basically attach these conditions that were revealed in this study to the identity of that person. So any questions so far about the setup? Okay. So next, the problem was not easy, because if we think of classification, it's like 2-person classification and so on. But this is about re-identification. So this is a lot closer to authentication, where you need a model for each person. So each person is their own class. And if we have 8 billion or 9 billion people on this planet, then each of them are their own class, for those who want to understand about it from a machine learning perspective. And so what we were looking for was a model where we could represent this motion sensor data such that we find the commonality in the traces of this motion sensor from the one individual across all the things that they do in their daily life. Sometimes we are seated, sometimes we are standing, sometimes we are typing, sometimes we are eating, sometimes we are walking, sometimes we are running. And in each of these times, our data is different. But we wanted to find what's common for this person. Is there a signature of this person, no matter what they do? Okay. So it's different than activity recognition modeling, where the purpose in the activity recognition is that no matter who is performing this walking, be able to detect that currently it's walking that's in progress. Here, our purpose is different. Irrespective of whichever activity they are doing, we want to iron out those signatures of different activity and hone in on the identifying signature of that individual. Second thing we wanted to do was that there are 100 participants, all of whom are walking. What we want to understand is that they are all walking. So those who work on activity recognition, they will identify that signature, which is of walking. Here we are saying that even though they are all walking, what's different about each of them as they walk? Is it their gait? Is it the way that they swing their arms? So we wanted to find the differences among these participants. And so we wanted to train a model that was able to maintain this consistency of signature within each person and distinction across different participants. Okay, so if pictorially, you could think of it like, here, if you think of representation of space in a 2D, then each of these are like the representation of data from each person, and you see they are overlapped. Or we could have a non-overlapping representation, but then if they are all tightly packed, then when we add more participants, then you could begin to see overlap. So we went with an open set formulation where we wanted to maximize the separation so that as we add more participants or more people, they will have enough empty space to occupy so that there will not be a collision of the same person, so that each person maintains their signature. So in terms of model architecture, we take the sensor traces, we extract small segments out of it, we extract features out of those small segments, then we obtain a class likelihood estimation. By class, we mean the person, to find out which person is this data most likely to belong to. Then we take, and if it's above a certain threshold, then they are ranked, and then we take the majority ultimately, which and if that majority exists, then that is the person that has been identified. If none of the persons in our database has a likelihood that crosses a threshold, then we declare that the person does not belong to this database. Okay. So we, to train this model, we use data collected from 350 participants who wore the sensors for 10 weeks. They were full-time workers. They wore it for 8+ hours per day. So that's generated about 300 terabytes of data, of all the modalities taken together. So for training and testing of our model, we split the entire data set into the training, validation, and then a separate test set. And then we wanted to see as to the impact of engaging in different activities as to how much data you need for re-identification. So we developed an activity model from an open data set in this case, which has 51 participants in various activity states. So overall re-identification risk, what we found is that if you share full day worth of accelerometry data from your wrist-worn sensors, then there is a 96% likelihood of re-identification. Okay. In terms of for different activity types, of course, when we are walking or exercising, then we have more variation in our data. And so you need less amount of data if you are engaged in certain activities. If you're stationary, there is not as much variation in the data. So then you'll need longer duration of the data in a stationary. So another question, as I said, we were interested in scalability. That means this model should be such that it scales to the entire world population. And so for that, we did a differential entropy analysis and showed that that this model can accommodate the signatures of 7.2 times 10 to the power 16 users, so which is a lot more than the Earth population. Okay, so that was about the model. So if we have a new study and we want to assess how much there is re-identification risk embedded in this in the data that we are collecting, so that we can decide, both to inform the participant of the risk as well as take precautions against, to protect against this risk or to mitigate against this risk. So first part is body placement as to where the sensor is placed. In our modeling, the sensors were placed on the wrist. It was both on the left and the right wrist, so that would not make much of a difference. We have tested that. We did not test against ankle, but the assumption would be that ankle would also be involved in several motion activities, not when you are stationary, but when you're walking or engaged in exercise that involves motion of the legs. Okay. The second factor is context. If there is homogeneity in what we are asking the participants to do, it does not embed their signatures as much. And so data collected in a scripted setting may not have as much of re-identification information as is in a free living natural environment where people do things at their own pace, which has more of their signatures. Context also means that if the data was collected while, let's say, I was on a hospital bed, it will not be as re-identifying to me when I'm finally healed, recovered, and I'm living in my natural environment. So when we think about re-identification, it is about re-identification when assuming that the data collected from the person that's in one database is similar to the context that person lives in when they contribute to the other database. So the most generalizable re-identification risk would be if the data was collected from a natural environment when the person was fit, healthy, and for both cases, when they contribute to the science as well as, to an open data set, as well as the data they contribute to an adversary. The third part is this assumes that data collection is raw sensor data. So that means the raw accelerometer, the accelerometry as measured in meter per second square, or in terms of gravity, or in terms of G. If you are only collecting the step count, then which is derived from the accelerometer data, but you are not collecting or releasing the raw sensor data, then this risk of re-identification does not apply. Okay. So finally, there is one more way. If you have collected raw accelerometer data, collected from the natural environment of the person where they are expected to spend most of their life, you can introduce artificial noise to the data while keeping the statistical properties still the same, and still significantly reduce the re-identification risk. Those of you who know differential privacy, the Laplacian noise is what's usually used in differential privacy, and that significantly reduces the re-identification risk. And so those are some ways. One is, if you're not collecting or releasing raw accelerometer data, then I don't think you need to worry as much. If you're collecting data in the natural, if not in the natural environment, but in scripted setting, then again, there should not be as much of a risk. But if you are collecting raw accelerometer data, then you can introduce some noise and then protect against privacy risks. That's what I had to present. I'll now turn it over to Camille. Camille, you're on the mute.
Okay, thank you. I'm going to go ahead and share my screen. So let's see, continue. So as Santosh and I have been working together, and he's been describing the process for re-identification. Let me see if I can do the slideshow here, play from start. I started asking questions like, how would the researchers know what they need to be aware of? And so this is the real opportunity to kind of bridge digital health researchers who tend to be behavioral scientists, background in psychology, health behaviors, behavior change. How do we bridge what the computational people are learning with the people who are designing these studies, that are deploying these studies, that are getting funded to do these studies? I also have the opportunity to work on the NIDA-funded Healthy Brain and Child Development Study, and I'm working in a working group that is focusing on wearable sensors that are being placed on infants. And so I worked with Santosh to help us understand how do we apply what he's learned in real life? Because not only does Bridge to AI have a requirement to put data into the public access, but Healthy Brain and Child Development does as well. And so thinking through, like, if we're putting data out for public access, we need to know where these risks are, and then we need to manage them. And so what I was doing with the working group for the wearable sensor in Healthy Baby or Healthy Brain and Child Development was we were about to post our protocol. The data are not public yet, but they're about to be launched. And so this is a study where babies, this is a complement to the adolescent brain and child development study that has been going on for 10 years with children from age 9 to 19. This is now the precursor to that, where they're enrolling pregnant moms and then placing sensors on the baby for 9 years. So this is going to be a very early stage. And we wanted to find out, like, is there a way that this baby could be identifiable? And so it's a large-scale study of infant health using wearable sensors. The infant wears a sensor device that is capturing movement and sleep data. It's placed on their ankle. It could be long-term identifiability risks. There could be unintended surveillance. And we wanted to kind of explore what are the ethical concerns when you're measuring baby movement. And again, babies don't consent, their parents consent for them. And so do their parents know, is there a risk around this? And so we really wanted to think about, do these conditions apply to this study? So here you have the risk print study where these are adults and there's unique movement patterns. And the HBCD, we have longitudinal privacy risks where the infant is wearing this device. Adults wearing a wrist-worn device, they have the ability to consent, where infants and young children in a developmental study don't. They rely on their parents. Here with adults, we have the 96% re-identification rate from a single day of data if there's a matched data set where they're identified. And so, with the babies, it's long-term identifiability. Can you do that based on their sleep patterns when they're, 2 months old? And so the ethical challenges are really balancing this research utility, having this very sensitive data that we can learn so much about people and their health and the different precursors to health. And now we have a vulnerable population. And again, what is the likelihood that they could be identified downstream? And so we applied those questions that Santosh noted. Is it wrist worn? Is it raw accelerometry data? Are they wearing it for 8+ hours a day? And so we applied that to this protocol and found that the likelihood of re-identification of a baby is pretty low because their movements are changing. And, it's a wrist worn device, or an ankle worn device. How does that change over time? And so the assessment was that it's very low risk. And so because we want to educate other researchers who are thinking about using different kinds of wearable sensors that measure activity, we wanted to write about this. And so this is a paragraph that I've written up for a manuscript that will be going out to a pediatric journal soon, just to let other digital health researchers know how we're thinking about making this assessment. Now, these babies, as they grow into toddlers, are going to start wearing wrist-worn devices. And so does that change over time? And so the need to do a reassessment is going to be really important. And so what we want to talk about with you all is thinking through what are the tensions for researchers, for IRBs, for sponsors, and for participants. What do we need to be able to tell them in order for them to make an informed decision? What should sponsors know before they make demands about data being public and available for download? How do researchers convey this to IRBs? And then how do researchers make decisions about the management of their data? So I'll stop there and just turn it back over to Lori to help, think through what should we be thinking about when we think about the tensions that each one of these groups might experience as they're thinking about use of digital health sensors.
Thank
And we
you.
can open it up for questions and I'll just turn it over to you, Lori.
Yeah, thank you so much. These were fascinating presentations, and this is exactly the kind of thing that this group, I think, is interested in hearing about and talking about. And so encouraging people to, raise your hand or come, turn on your camera or whatever, like somehow call attention to yourself, or you can put something in the chat too. I need to bring that up. But so one question I had was, Dr. Kumar, you talked about some strategies for reducing the re-identification risk, like introducing noise. And so I have a question about that because, and I'm not a data scientist, and so this might be a dumb question, but if you introduce noise into the data, it seems like that would change the utility of the data for some particular research questions. And so is there a way to characterize that for researchers? Like, here's what we've done with the data. So if you're wanting to look at, if dates are important to you or whatever, like, is there a way to kind of summarize that and visualize that for researchers so they understand? And you're on mute.
That's a very good question. In general, these perturbations are meant to introduce noise at the very short time scales and to preserve the statistical characteristics of the signal. So in most cases, they should not adversely impact a large majority of the utility. So you should still be able to detect major activity classes. You should still be able to detect their steps and so on. But if there are some fine-grained of activity like opening the door, or like that occurs for a very short time and has very faint signature in the data. So those are the ones where, like opening a can, or or opening a, like for medication adherence, like opening a pill bottle. Or opening the cap of the toothpaste. Or like, so there are some activity that happens for very, very small time, and with the signature is not very profound. That's where I would say that there may need to be a careful analysis whether these noises do adversely impact the accuracy of those inferences. But majority of the activity classes that like a step takes a second. Within that second, there are so many peaks and valleys in the accelerometer. So it should not be an issue.
Interesting. Okay, thank you.
Sure.
So I'm not seeing questions. Camille, have you thought much about visualizations for this?
Well,
Like,
we are trying to think through, like, how do we provide education for researchers to help them understand this component of the computation, the science behind being able to detect somebody unscrewing the cap of a toothpaste. Like, it didn't occur to me that these kinds of just everyday behaviors, I didn't know that the technologies were that sensitive, and that these kind of things can be known if you have the skill set like Kumar and his team. And so, coming from behavioral medicine and public health, we want to use the tools. The tools do the things that we want them to do. We purchase tools if they're like affordable. So we make a lot of decisions about what tools we're going to use in our digital health studies without knowing. And researchers tend to want to get as much data as they can. So this raw accelerometry data is really the key. So do most researchers know that they have that data? I think so, because they would want to have as much granular data as they can possibly get. That's just the nature of researchers. They want as much as they can get to answer questions that they don't even know they have yet, which is great. But the fact that maybe they're being asked to make that publicly available and don't have this understanding that combined with other data that are out there, it can be potentially you can't guarantee this de-identification to research participants. And so what it does for me is it tells me we need to do more to educate our research community. We also need to do more to educate sponsors, because I think that these kind of things can be managed. We just need to help people understand that this is a risk that we need to be thinking about, and not push, researchers, I think, want to do the right thing by their participants. So acknowledging that these kind of things are possible, it's not to scare them off, it's to really help them understand that, we all need to be responsible in this age of new technologies and granular data. So visualizations, we've been working on that with our team. Like, we just published this paper that Ramona was involved in, and a couple of my teammates on this call, where could we augment informed consent with data flow diagrams? And, looking at a company like Fitbit or a company like Talkspace,
right.
what's in their terms and conditions, what's in their privacy policy, so we know more about what kinds of data are being collected, stored, shared, disseminated, and then we can visualize what those look like so that they can augment a consent. They could augment a IRB protocol just to kind of increase awareness of data and data flows.
And I think that would be helpful for the researchers themselves to be able to see, like, these are the points in the process that are risky, and then here are the potential solutions to that. Yeah, we did a study one time where we were having people working in ambulances wear sensors because we were trying to gather information to automatically chart their actions. So like if they were doing this, it would be chest compressions on a patient and it would automatically chart it. And I can imagine lots of, risks for those participants. This is your profession, and what you're doing with your hands, you could get sued for, right? If you do something wrong. And so lots of potential things that could happen when you're gathering this level of data. Other questions from the group? Brad, I see you turned on your camera.
Just trying to be a pleasant face.
And thanks for doing that. I really like seeing people when we have these conversations. It makes it more like a discussion. So thank you.
So, okay. So you know that I eat, sleep, and breathe this problem. So I want to push on one fundamental question. And that is, so how do you justify the plausibility of the adversarial model here? I mean, the reason why I'm asking the question is, so you're at what point are you going to proclaim that the sky is falling and that there's imminent danger such that these data sets need to undergo the type of amendment that you're talking about? Is this only in the situation where it's going to be a public use data set, like fully public? Is it in the situation where it's going to be semi-public, where there's going to be some contractual agreement or licensing agreement for the end user? Is there going, I'm just curious on how you think about this, because I know how we've thought about this in other projects.
I would love to hear more as to how you have thought about this for other projects. So here, I think our motivations were to communicate to the community that this is now possible. Now, after you know that it is possible to link two data sets just based on the wrist-worn accelerometer data, the researchers can themselves decide as to whether, given what they know today, without claiming to know what will come tomorrow, do they believe that this risk needs to be communicated to the participants? And do they need to plan any contingencies? Now, for this case of being able to share the raw accelerometer data, I will take my own case as a consumer. Before knowing this, if my auto insurance company said, okay, we'll give you a 20% discount, just share us the data from such and such. Say, yeah, 20% discount, someone saves $200 a year or $100 a year. I would like to give this a try. Now that I know about it, I will have to think a lot more carefully as to today, I'm contributing my data to this insurance company, so which has this kind of, motion sensor data that they largely use it for my driving habit today, how hard I brake, how much I accelerate, how much I change lanes, all of which can be computed out of the motion sensor data. But then what else will they know tomorrow? And the same insurance company, it's a business, and say, okay, now we have started offering this new insurance service. And so they branch out, they have access to that data. They are now into a different surface. They can make different utility out of my data. So it changes the perspective or changes it forces a reappraisal, knowing what we know. Now, is this the sky falling? Perhaps not. Is this about revealing a new capability that we didn't know before? That's how we are taking it.
Yeah, but I would point out that I think you're conflating two different privacy issues in your response. So the first one is the identifiability issue, which is a linkage question.
Yes.
And the second one is an inferential disclosure problem, which is, do we really understand everything that's in the information that we're passing over to somebody who knows the identity of the individual to begin with? That second one's really hard, right? If we don't know everything that you can infer from the information. You know, like in the EU, unlike in the US, you know, they say that if you're going to make a claim of anonymous with respect to the data, then you need to show that it's not linkable. You also need to show that it's non-inferable, which is an extremely heavy lift, right? Because that implies that you understand like all the information that could be squeezed out of the data that you're providing to them. But we don't take that stance in the United States, right? And I think the reason why I'm pushing on this so hard is I think I would disagree with you on the issue that it's the responsibility of the investigator to communicate the risk, because I don't think that investigators know how to calibrate risk or how to communicate risk. And so I'd love to hear from Camille about like what that would entail.
How to communicate risk to researchers or to
Potential data contributors to a research study.
How the
Yeah.
researchers should contribute it to them.
Say that again, Lori.
How the researchers should contribute it to the how the
Yeah.
researchers should communicate it to the participants.
Well, first and foremost, should it be the researchers?
And the tension comes in because, they really know that this tool is going to capture the data that they want to answer their research question. And so they tell people that there's this risk and they try to quantify it and they say what they're going to do to mitigate this risk. You don't want to scare people from participating. And that goes kind of to Ramona's question in the chat. Do we have a sense of how often research participants are re-identified based on open data sets? I don't think we know the answer to that question yet. And the other thing is, Brad, is that we have a really hard time finding out when there is a re-identification what the harm was, because oftentimes risk management people or whoever gets involved in that identity protection, we never hear the story. Those are kept under like lock and key. So I guess, telling people, I really question informed consent anyway, because I think we give people too much information and they come out with just cognitive overload and they can't digest it. And so you have to have sufficient technology literacy, sufficient data literacy, and sufficient research literacy, which probably 3% of our participants have. So I think, building on a foundation where there is not sufficient literacy and then telling them these things, it's not going to help people make decisions. I think it will help researchers to know potentially when they need to push back on a sponsor that's demanding that raw accelerometry data be put into a publicly accessed data set. And again, depending on how that repository is set up, what kind of access controls there are, this is really more of a system issue that we need to think through, not can the participant consent. So I really think we need to have the sponsors be very well educated and the researchers be educated enough to know when they need to say, this wouldn't be the right thing to do because of these reasons. And see if they can get that kind of data protected in some form because of the noise that Dr. Kumar was suggesting. You can manage it. But I think it's more the responsibility of the research ecosystem than it is for that participant to understand what they're consenting to. I think that ship has sailed. I think we put way too much weight on people consenting, and then we use that as the gate to say we can do whatever we need to do now to pursue this question.
I keep feeling like there's another level kind of higher where it like at the societal level that we all need to start becoming more aware of these types of risks. And I wonder if there's also a need for transparency and I recognize this is like a pipe dream, but transparency in these data relationships, these contracted data relationships, because I mean, I think it's not all like criminals. A lot of it is this company just bought that company, so now they have all their data. And is there some way that we could all see an accounting of like who owns whom and where is my data going?
Yeah, pipe dream. Yeah, I just, I think when I thought about this back when I was working with the All of Us research program about, this issue of literacy came up and how do you educate? How much weight should informed consent have? And there was a lot of effort to put out bite-sized bits of education, that would help the research participant in little chunks learn things about this data ecosystem. I don't know where that went. The same is true when I think about Q&I research, quality improvement, where in let's say a federally qualified health center, they're constantly using the electronic health record to learn about their patients, to make incremental changes in their processes for managing their patient throughput. Sometimes that influences decisions made by the clinicians, but it's all happening in the way background where the patient never knows how that data that's in their electronic health record is being used because it's not considered research, it's quality improvement, so they never have to consent for that data to be accessed. But at the same time, how do you demonstrate respect for people who use that clinic? And you could do something as simple as signage to let people know how their data are being used. You use little tiny things in the portal to tell them if you want to learn more about this, click here. So I think that this need for education couldn't be stronger. But how do you do it? And that's one of the things that Dr. Kumar and I are doing. And we've been experimenting with, using a large language model and submitting these use cases and asking like, what would a short module, an educational module designed for a researcher that has this background, what would an educational module look like? And what components should be in it? And then you can ask it the same thing from a computational scientist perspective. Because the first time I put that query in, it came back with so many more formulas than I'd ever want to look at. Like I've told Santosh, every time these formulas come up, I just start getting blurry-eyed. But how do we do this in a way that just continues to demonstrate capacity building and respect?
Great points. Other comments or
I
questions?
think so. I'll jump in. Sorry. No, I'm not sorry. So I think at the end of the day, there's a notion of accountability that's critical. And one of the reasons, so we've done a lot of research on this and trying to model this problem as under what circumstances would people commit re-identifications. And it has to be worth their effort. And if there's no deterrence in place, right? So what Santosh is talking about is a data-driven deterrent, which is that I'm going to inject noise into the data so that if you commit an attack, it's going to be difficult for you to be successful, which means I don't trust you at all, right? There's zero trust in that situation. It assumes the worst in people. And I don't like living in that world. That makes me really upset because then what it says is that he doesn't trust me, right? And so I think that what we do today is that we set up contractual terms, and that if somebody violates those contractual terms, then there's some type of potential penalty that the individual will end up reaping as an artifact, and that's deterrence theory. Now, we don't always have to say that there's going to be a penalty. There could be an incentive structure as well, right? But there has to be some type of an interplay. This is the way that we set it up over at All of Us, between the notion of like data-based protections. You don't want to make it easy for somebody to commit a re-identification with contractual legal-based obligation that injects some measure of accountability onto one's actions. And there has to be like some type of a happy marriage there. That's why I was pushing for it. Like I really don't think that at the end of the day, the researcher should be trying to figure out, even if an individual consents to be part of the study, and now the researcher has to say, well, I'm going to do some type of an injection of noise. Now, let's say they do the noise injection, and by random chance, they don't inject enough noise, right? Could happen, and an individual is successfully re-identified. Well, then who's accountable at that point? Was it sorry to the participant? Was it the researcher who didn't inject enough noise and they didn't understand it? Was it the privacy professional that assisted the researcher in doing that type of a protection? Or was it the person who committed the re-identification in the first place because they violated terms?
Yeah, I'm just really happy that we're having this conversation because I think that these are the kind of things that in a program like Bridge to AI, where you have privacy experts, computational scientists, people that, really understand that aspect, working with people like me and Lori, who's an anthropologist. We have such an incredibly diverse group of people here that it's just, I really appreciate the opportunity to have this discussion and comments. Joe, do you want to go ahead and say what you put in the chat?
I want to say I agree with Brad. I don't want to live in that world either. I'm a scientist. I grew up thinking that data should be open, but that's not the world we live in. Increasingly, there's these public and private partnerships between federally collected data that aren't always transparent. And as for native tribes and specifically, technology since 2008 has made indigenous spaces a target for looking for new data and resources that stem from that data, whether that's rare earth minerals, water, botanicals for pharmaceutics, or human DNA. And we are not bioproperty, and we do not consent to give over our data for these private companies to turn into pharmaceuticals.
Thanks, Joe. And Ben, did you want to add your comment?
He may be gone. Oh, no, he's still here.
What is it about the EU regulations that seem ill-conceived?
Apologies, I think my microphone was on the wrong audio card. Yeah, it seems it's kind of like a fundamental logical principle, like proving a negative. Obviously, it's not that you can't, it's that typically the space is just exponentially large to do so. And so it seems just most wearable data is going to be too complex to essentially say this is definitely not anonymized. And even if you kind of place an inductive bias over the data. And so just the premise alone seems a little bit ill-conceived. And I was just kind of wondering if that's something that is kind of discussed.
So for about 5 years, I sat on the technical anonymization group for the European Medicines Agency, and these types of questions came up, many situations. The answer is that the way the EU does it is that they really focus heavily on privacy impact assessments and the design of plausible adversarial models. And so, this question of is the high dimensionality and inherent complexity of data sufficient to claim that you can't provide any guarantees of protection, or any, maybe not guarantee, but at least some strong evidence to suggest it will be protected? I think that the way that they tend to think about it is that if there's no evidence at the present moment in time, and under a plausible adversarial model, if you can't show why somebody would be sufficiently motivated given the terms around it, it would be justifiable for sharing it and claiming that it's anonymous. And the same thing in the US where it would be de-identified, but in the EU, they definitely require the privacy impact assessment in order to do so.
Okay, yeah, that makes a lot of sense. Thanks, Brad.
I think the bigger problem that we have in the US is that we really don't have a centralized clearinghouse for privacy protection mechanisms, for threat detection and protection mechanisms. And in the EU, they have data protection authorities and information commissioners' offices in various countries. We don't have anything like that. And that creates cowboy country over here.
On that note, I want to thank our excellent speakers today, Dr. Nebeker and Dr. Kumar. This was a great conversation, and thank you, Brad, for offering your insights as well. So next time we have Dr. Glenn Cohen speaking on hospital implementation of medical AI, legal and ethical issues. I hope you'll come back for that. And thank you again, Camille and Santosh. This was excellent.
Thank you so much for inviting. I really enjoyed, learned quite a bit.
Thank
Thank you.